We got one more left.
All right, so our final CMSACamp presentation will also be talking about hockey, this time talking about drawing power plays. So we have Katherine Gong from Mount Holyoke College and Bethany Gonzalez from the University of Indianapolis, both very soon to be graduates of their respective institutions and great candidates should you see any applications come your way. So take it away.
Thank you, Mac. Hi, everyone. As Mac mentioned, my name's Katherine, and I'm a senior at Mount Holyoke College. And my main responsibility in this project is for the visualization and the development of the Shining app.
I am Bethany. As she mentioned as well, I go to the University of Indianapolis. I'm majoring in math, and I will graduate in December, as long as with Katherine. Hello, sorry. In the 22-23 NHL hockey season, Connor McDavid and Michael Bunting led the league in penalties drawn. Bunting was in second with 43 penalties drawn. However, in this same season, he also took 42 penalties. So this led us to wonder and be curious if penalties drawn is a good enough or adequate statistic or metric for evaluating whether players are good at creating power play events for their teams. As Luke and Quinn talked about, gentle reminder, power plays are when a team has a numerical advantage over the other team. So we were curious about that, or are these penalties that are being called being offset by penalties that are also simultaneously being taken, so then resulting in no power play event, resulting in no advantage for the team. And then with that, we wanted to identify what players are the best at drawing power plays for their team. So to explore these ideas and questions, we used play-by-play data from Hockey R, and then player statistic data we scraped from Natural Stat Trick. Obviously, play-by-play data is quite large. We looked at the past 10 seasons, and for each season, there's around 100 variables and around 38 to 40,000 observations or entries. We specifically looked at like penalty events, so that shortened it a little. So then for this, and you'll see, I'll talk about more on the next slide, the three things we created or metrics were penalty on or penalties taken, drew by, and power plays drawn. Sorry, didn't want to mess that up. So important to note that when we calculated our penalties on or taken and all these statistics for events or penalties that are called simultaneously, or like penalties, called all at the same time, we only credited players once for each of these metrics. So that's to say that if you added up our penalty on statistic, that is not giving you the sum of that player's penalties taken for that season. After cleaning all this data, I won't bore you because the data is messy, so I'm not going to bore you with how I did that, but there's this beautiful shiny app. This is the clean data. This is a screenshot, and you'll see that later on. So as mentioned, the three variables we kind of made were penalty on or penalties taken. So that's the player who's guilty of the penalty. Drew by, the player who drew the penalty, and drew power play. So that's the player who drew the power play. In the play-by-play data, it provides players 1, 2, and 3 for each event. However, for penalty events, this did not correlate or translate that player 1 took the penalty, player 2 drew the penalty, and player 3 served the penalty. Because of this, we ended up having to do string analysis on the description column. So that's a little bit of a limitation because it's words. String analysis can cause limitation because the data's entry cannot be always measured accurately. However, in general, for the most part, there are 4 different categories that this description column kind of fell into, or pattern. This is based off the words against and served by, and whether they appeared and how they appeared in the data. So as you can see from this, the first category is if it just has the word against. The second category, if it has neither. Third is if it has against and served by, and fourth, if it has served by. And then you can see how we assigned the penalty on or drew by statistics accordingly. Now that we had the raw counts of this data, we realized that that's not sufficient in evaluating a player, especially comparatively speaking, because imagine a player who doesn't play as many games and comparing them to someone who plays like every game. It's unfair because the player who doesn't play as many games doesn't have the opportunity to create as many power play events for their team. So in order to account for this, we used the raw counts we calculated and the data we scraped, the time on ice data and games played data for each player, and created a per 60 stat for the power plays drawn. After we created this, we wanted to measure the repeatability of this metric. So we took a player's power play drawn per 60 stat, or used a linear regression model, and used that to predict their next seasons. Given the R-squared, we found that on average, 30.5% of the power plays drawn per 60 for a player is explained by the player's previous year's stat.
And now we are going to talk about some direct results through the visualizations, but I do want to mention that all the visualization we are presenting have an interactive version in our Shiny app. So if you want to take a look at that, you can scan the QR code. We also have the code at the end of this presentation. Okay. Yeah, so the first visualization I'm presenting is like very self-evident in itself, like who are the players that is best at drawing power plays based on the per 60 metric that we created. So we have this bar chart that lists the top 10 players enjoying the power plays by the per 60 metric in the 22 to 23 regular seasons. And we only include players with more than 10 games played because we want to keep our per 60 metric consistent and stable. And you can also notice that these players, they are not the players who we usually refer to who are good at drawing power plays based on the raw counts, because as Bethany mentioned before, those like raw counts are accumulated throughout the seasons. And for like players has like less opportunities on ice, it is like unfair for them to prepare that way. So we really believe that this like standardization of the time on ice give like a more like realistic representation of the player's capacity in drawing power plays. And also, it is like very unlikely for this player listed as the top players to be enforcers, because like enforcers are more likely to engage in the offsetting penalties that does not lead to power plays. And after knowing who is really good at drawing the power plays, we really want to compare that to the penalties metric that we have traditionally. And so in the left, we have a bar chart that is ranked by the players who has the most penalty drawn per 60, and which is shown in the dark blue bars. And as the light blue bars, we have the power play drawn per 60 for the same players. And you can see that for the most players, there's like a huge gap between these two variables, which demonstrate that a lot of this penalties the player draws are offsetting. And it is like more evident to look at the right side, which we have like players ranked by their offsetting penalties drawn per 60. So what we are really trying to show in this slide is that the penalties metrics that we have been traditionally rely on might not be as valuable as we think, because it's not considering like the offsetting penalties and like that are not actually bringing advantage to the teams and might in fact like harm the team's interest, because now both teams has player in the box. So that's really what we are trying to say in this slide. And we also conduct the positional analysis based on the data we have. So in the x-axis, we have the penalty taken raw count, and the y-axis, we have the penalty drawn raw count. And you can really easily to tell that like offense players, they are more likely to draw power play given the same amount of penalty they take, which is related to their role within the teams and within the games. And we also highlighted the players who draws the most power plays by the raw count, and you can see that all of them are offense. And we have like consistent result between like this raw count and the per 60 metric that we have. And we also constructed similar analysis for every team in the league so that we can have like a league overview. So what you can notice is that there's like a very evident positive relationship between these two variables, because like this is the NHL league is executing what is called the game measurement. So they're trying to give like the similar amount of penalties for players within the game. And because of that, it is really valuable to know which player is actually good at drawing power plays that are the game changers rather than like offsetting penalties. And you can also notice that like for different teams, there are different slope like between these two variables. And we think that is a reflection of the team's performance style like in their engagement with the penalties. And now we're trying to talk about something that we did recently and that are like still in development. So what we did is like a power play breakdown based on the penalty types, because we are really interested in what type of penalties are actually leading to power plays. So what we did is we calculated the top 6 type of penalties that lead to power plays, and we mapped that into the first plot that you see. So you can see that like for different players, the like types of penalties that lead to power plays are really different, which is like very evident because different players, they have different roles within the teams and they have different playing style. But just for the 22 to 23 regular seasons, we can see that tripping is like a very big one in like leading to power plays and also hooking and interference. And I do want to mention that like for different seasons, these like top penalty types that lead to power plays are very different because like the referees will tend to call different type of penalties in different seasons. And you can like explore our analysis for the past 10 seasons in our Shiny app.
The second thing we've done is look at when goals happen during power plays. So currently in the league, when a power play is happening at the end of a game, if the game ends before the power play ends, they cut the power play short. So over the summer, we were interested in looking at what would happen if we extended the game to play the full power play out. Does that change the game outcome? And would that even change a league outcome or, season outcome? So the first step of this that we've done is look at the distribution of goals over a 2-minute penalty or like power play really. So this is a 2-minute penalty goal time distribution. This is all 10 seasons data in one, this one on the right. So you can see a high peak right at the beginning, actually 7 seconds is right there. So most goals happen at the like 7 seconds into a power play. And on the left, no, right? Sorry, I don't know my rights from last, but this one over here is a ridge plot showing the distribution for all 10 seasons. And this is just to highlight that it seems that a similar pattern, as in most goals happen during the beginning of the 2-minute penalty rather than the end. With notable 2018-19 has a little bit of a peak at the end there, but it's not as high as the peak at the beginning, which can be explored further. There are limitations to this as we're only looking at 2-minute right now because well, most penalties called are 2-minute penalties. So there's a lot less data for the 4-minute, 5-minute, and then, yeah. So that's why we're only at 2-minute. And then also the way that we found this data or made these plots was through loops and decisions. And unfortunately, data is not always perfect. So there may be some misaccounted for. The next steps in order to do the modeling we want to do is looking at when or how far into power plays games are often cutting them off. So if it's accurate that like they don't cut them off most of the time until like the very end, or they only let them play for a minute, and just looking at how that distribution looks like and seeing, because while this does have a peak at the beginning and most of them show that at the beginning is when most goals happen, there is still a steady middle section. I don't know how to say that. The middle section is still pretty steady. So goals are happening all, like in the middle as well. So it may still change game outcome if you see towards the end.
Yeah, these two plots are not in our Shiny app because they're still under development, but we're really excited to add that in the very near future. So like another limitation of our project is the threshold of 10 games I mentioned before, like in our per-60 analysis in the regular seasons. And because like in the playoffs, like teams usually play fewer games, so we have like lower bar of the threshold, which is at 2 games. But that will like introduce some bias into our per-60 metric because that's like 2-game like threshold inevitably give more weight to players that has like lower time on ice. And I also want to mention that this filter will like unintentionally exclude some players with like probably very good ability in drawing power plays or penalties, but didn't have a lot of chance in like playing during the season. So I do want to like keep you in mind with that. And the other limitation in data and like the time distribution things, like Bethany has already mentioned that. And some future steps that we are interested in doing is first to update our research for the current 23 to 24 seasons. We are very excited to incorporate that data into our Shiny app so that like you can play around with it in the most recent data. And the second thing is that for the power plays breakdown by the penalty types, we want to do that in a team level because we think it will be more valuable for the team to know that what type of penalties are more likely to lead to power plays rather than a current like more individualized level of analysis. And we are very interested in like modify the data pipeline and resolve some like existing issues that is related to the string analysis that we have mentioned before. So this is all we have for this presentation. Thank you so much for listening, and thank you CMU for having us here today. Thank you the Penguins for your guidance throughout this project, and thank you Ron and Meg for your teaching during this program. Thank you.
All right.